Let's work through longest substring with same letters after replacement problem. Given a string with lowercase letters only, if you are allowed to replace no more than k letters with any letter, find the length of the longest substring having the same letters after replacement. For example, if the input is this and k is given to be 2, the output will be 5 because we can replace the two C's here with B to have the longest substring that consists of 5 B's. And in the example 2, we can replace the C with B to get the 4-letter B's, and the output will be 4 in this case. And in the last example, if we replace B with C, we get these 3 characters as the longest substring having the same letters. So that's one possibility. We can also replace D with C. That will also give us the output of 3 because K is given to be 1. So we replace just one character. Same in this case. We have only one character replacement. In this case, we replace 2 characters to get 5. We can use sliding window, specifically dynamic sliding window, to solve this problem. And we'll use the hash map to count the frequency of each letter. We will iterate through the string to add one letter at a time. We will iterate through the string to add one letter at a time in the window. We'll also keep track of the count of the maximum repeating letter in any window. We'll call that as max repeat letter count. So at any time, we know that we have a window which has one letter repeating max repeat letter count times. This means we should try to replace the remaining letters. If we have more than k remaining letters, we should shrink the window as we are not allowed to replace more than k letters. String is aabccbb. We will initialize the variables window start, max length, max repeat letter count, all to 0, and k is given to be 2. Frequency map is initialized to an empty dictionary. Window end begins from 0. Right character is A. The character at location 0 is A, and it's not in the frequency map. We will add it, and we will let the frequency of that letter be 1. And we will find the maximum of repeat letter count to be previous max repeat letter count and the frequency map of the right character. So in this case, max repeat letter count becomes 1, and this condition is not true, so we find the max length by finding the difference of the window and adding 1 to it. So max length now is 1. Now window end is 1, and this character is already in the hash map. We make it 2, and we find the max repeat letter count becomes 2, and the difference of window end and start is 1 plus 1 is 2, minus max repeat letter count is 2. So that condition is not satisfied. We find the max length, and the max length is now 2. Window end is 2, and this character B is not in the map. We will add it and let the frequency be 1. We find the max repeat letter count, and that's going to be 2. It remains at 2. and we find this conditional to be false. We find the max length. Max length is now 3. Window end is 3, and the character at that location is C. It's not in the hash. We add it and let the frequency be 1. Now the max repeat letter count is calculated, and that is still 2. This condition is false, so we find the max length, and that becomes 4. Now we find the character at index 4. That's going to be C. It's already in the hash map. Its frequency goes up by 1. Max repeat letter count is still at 2. This conditional is now satisfied. The difference between window end and window start is 4 minus 0 is 4 plus 1 is 5. And if you subtract max repeat letter count, which is 2, so 3 is greater than 2, so it's satisfied. So we find the left character, which is A, and the frequency of the left character in the map is reduced by 1, so it becomes 1. Its previous value was 2. Now window start is bumped up 1 above its previous value to 1. So max length now becomes 4. It stays at 4. Window end becomes 5 from 4, and the character at that location is going to be B. It's already there in the hash map. Its frequency is now set to 2, and the max repeat letter count is still 2. And this condition is satisfied, and the left character is A, and we reduce its frequency by 1, and we increase the window start by 1. So it's going to go from 1 to 2. The max length stays at 4. Window end is now 6. Right character is B, and it's there in the hash map. Its frequency now is set to 3. Max repeat letter count becomes 3 from 2, and this condition is not satisfied. We find the max length, and it's now set to 5. So old value was 4. Window end is reached the end of the string, so now max length is 5. We return that value, and that is printed. Now we have A, B, B, C, B with k value of 1. We have variables initialized to 0, and window end is 0, and the character at that location is A, and we put it in the hash, and we increment from 0 to 1, so it takes a value of 1. Max repeat letter count is 1. That's not satisfied. We find the max length to be 1, and window end is now 1. The character at that location is B, and it's not in the hash map. We add it and set the frequency to 1. Max repeat letter count is 1, and we find this conditional not satisfied. Max length is now set to 2. Right character is going to be B. It's already in the hash map. It's now set to 2 now. Max repeat letter count is 2. And the window condition is not satisfied. And the max length is now 3. Window end is 3. And the letter at that location is C. And C is not in the hash map. We add it and make its value as 1. Max repeat letter count now is staying the same. This condition is now satisfied. Window end is 3 minus 0 plus 1 is 4. Minus 2 is the value of max repeat letter count. So it's 2 is greater than 1. K is 1. So it's now going to find the left character, which is A. And its frequency reduced by 0. Window start now is going to go from 0 to 1. Max length stays at 3. Window end is now 4. And the character at that location is going to be B. It's already in the hash, and we bump up its value by 1, so it becomes 3. Max repeat letter count stays at 2. And we find the window end. 4 minus 1 is the window start, so we have 3 plus 1 is 4 minus max repeat letter count is 3, so we get 1. 1 is not greater than 1, so we get out of the conditional, and max length is now 4, and the window end has reached the end of the string, and the max length of 4 is the return value, and it's printed. And the last test case, aabccde with k equals 1. Window is beginning with 0th index. A is put into the hash map, and we set its value to 1. Max repeat letter count is 1. And the max length is set to 1 now, and window end is 1. And the character at that location is B. We will put it into the hash and bump its value. Max repeat letter count stays at 1, and if window end minus window start, that's false, so max length is now set to 2. Window end becomes 2, and the character is C at that location. We add it to the hash, and we set the value to 1. Max repeat letter count is still 1. This condition is now satisfied because window end is 2 minus window start 0. 2 plus 1 is 3 minus max repeat letter count is 1. So 3 minus 1 is 2. That is greater than 1. So we find the left character, which is A. We reduce its frequency by 1. It becomes 0. Window start now is bumped up by 1. And its value is going to be 1 from 0. Max length stays at 2. Window end now 3. And the right character in that location is C. It's already in the hash map. We increase its value. We find the max repeat letter count, which is staying at 1. Now again we find the max length is set to 3. The right character is D now, and it's put into the hash, and we set the frequency to 1. Max repeat letter count stays at 2, and this is now satisfied. Window end is 4 minus window start 1 is 3. Plus 1 is 4 minus max repeat letter count is 2. 2 is greater than 1, so I now find the left character, which is B, and we reduce its value by 1. And the window start now becomes 2 from 1. Max length is set to 3. It stays at 3. Right character now is E. It's not in the hash. We set its value to 1. Max repeat letter count is still 2. And we find the left character, which is C. And we reduce its value by 1. And window start now goes to 3. Max length stays at 3. And that is written as a return value, and we print it.